Okay, so let's look at this question that brings together the bit of theory we did on corresponding and alternate angles and all that stuff, and then part B, which examined similar triangles. Okay, so find the value of x. Okay, the diagram shows the triangle ABC. DE is parallel to BC. Okay, whenever you see parallel lines in a question with angles, make sure you keep your different types of angles in our head. Okay, because these often come into play when you have a question like this, and that's with the parallel lines. Okay, parallel lines and then another line. Find the value of x. Okay, well, they're triangles, so angles in a triangle equal 180 degrees. Okay, so if I could find the three angles in any of the triangles, I could add them up to 180. Okay, so I'm going to try forming an F. Okay, so remember from our theory, our corresponding angles was the F shape. Okay, so let me draw in an F. Okay, and under the arms of the F, the angles are equal. Okay, so what does that mean? Well, I can say that that angle there is now 70 degrees. Okay, in a similar way, I could draw another F this way. Okay, I'm just drawing it outside the triangle so that you'll be able to see it. Okay, the arms of the F have to be the parallel lines. And in this case, under the arms of the F are the corresponding angles. So I can now say that this angle up here is 3x. Okay, so in the big triangle, I have three angles now, 2x, 3x, and 70. In the small triangle, I have the same three angles, 2x, 3x, and 70 degrees. Okay, so 2x plus 3x plus 70 adds up to 180 degrees. Okay, 2x and 3x is 5x plus 70 is 180. Subtract 70 from both sides. This is just a normal algebra question now. So 5x is equal to 110. Divide both sides by the number in front of x. X is 22 degrees. Okay, which means what? Well, it means this angle here is 44 degrees. It's 2 times 22. This one here is 66 degrees. And we know this one here is 70 degrees. 6, 7, 8, 9, 10, 11. They add up to 180 degrees. Okay, so yeah, 22 looks good. Okay, now the next part. Given that AE is equal to 100, AC is equal to 130, and DE is equal to 74, find the value of BC. Well, the first thing I was noticing when I was drawing these is that these triangles are similar triangles. Okay, how do I know that? Well, their angles matched. So you see the small triangle here, ADE. Let me draw him out. So A, D, and E. So he was 2x. So maybe I'll call him 44 degrees now. He was 3x, which is 66 degrees, and he was 70 degrees. Or do you know what? Let me not call them 44. Let me call them just 2x, 3x, and 70 in case that's what you called them. And then consider the big triangle. So ABC. Well, this angle at A is in both triangles, so that's still 2x. We saw that this one up here was equal to 3x. And I should have said y, so corresponding angles. Okay, I should have written that down somewhere. That's better. So that's a 3x. And of course, we know he's 70. So those are what we call similar triangles. We know that because their angles equal each other. Now their sides obviously don't equal, so they're not congruent triangles because you can clearly see that AE is shorter than AC. AD is clearly shorter than AB, and DE is clearly shorter than BC, okay? So they're not congruent triangles, because remember, congruent to same sides, same angles, they're similar triangles. But if they are similar triangles, their sides are in proportion, or they're in the same ratio. So we can say that that side AE, they're the matching sides, and you know that because we have the angles lined up. So now the sides on the left are in proportion. The sides on the right are in proportion. ED, and because I started with the smaller triangle on the top, I have to keep the smaller triangle on the top all the way across over BC, and that's also equal to the bottoms line up, AD over AC. Okay, so that's what the theorem on similar triangles tells me. Their sides are in proportion. You only typically use 2 bits of it at the one time. Okay, not all 3. Which 2 bits do you use? Well, it depends on the information they give you in the question. So let's fill this information into our theorem that we've set up here and see what we get. So the first one I have is AE is 100. So there's my AE. So let's replace that with 100. Equals. I have AC next, being 130. Let's find AC. It's over here. What was that? AC was 130. DE was my other one. Where's DE? Up here. 74. Find the value of BC. I'm wondering what I took down wrong. Ah, look at that. I labeled my triangle wrong, didn't I? Right, so just explain the mistake that I made, okay? So you see the way on none of the 2 of these did I have enough information, okay? Because if I'm to find X, then I need to have 2 pieces of information here or 2 pieces of information here. So when I saw this, I knew I'd made a mistake somewhere, okay? Because they can't do this to you. If you're to find X, then you need to have another pair. So that's when I knew I either made a mistake here, taking down the sides, and they looked okay. So therefore I must have made a mistake in my diagram. So AED is okay, but look at this one. C is up here and B is here, and I labeled them the other way around. Okay, so let me check that my right sides are here, because these are going to be also wrong. I now have AE over AC is equal to ED, that's fine, over BC is fine, because CB or BC is the same thing, which is equal to AD over AB on the bottom, not AC. Okay, so apologies for that now. So what does that do to here? I'm going to rub this piece out now. Okay, so let's look at what they gave us. So AE was 100 over AC was 130. Okay, so now you can see that I have a completed pair, and that's indeed what I would expect. DE, ED is the same thing, is 74, and they want me to find BC, okay, where I put in X. Okay, so that makes more sense now. This is the one that I don't need to use in this question for now, because I have no information about it. So just like we did on the last question, let's cross multiply. So that means multiply this cross by each other, so 100 times x is equal to, let's multiply this cross by each other, 74 times 130. Okay, so into my calculator, 74 by 130 is 9620. Divide by the number in front of 100, or in front of x. So divide that by 100, and I got 96.2 for that length of x. Okay. So I hope that makes sense. It looks good. The one on the bottom is bigger than the one on the top, so I expect this to be a bigger number. Okay. If I look at my ratio, if I multiply 74 by 100 over 130, multiply by, I do indeed get 96.2. Okay. So I hope that makes sense. That's how you use similar triangles. So corresponding angles, alternate angles, vertically opposite interior, so important in the geometry chapter, and also similar triangles.